Early last year, I delivered a webinar of the same name, and it's been about a year and a half, so it's time for us to revisit the topic of developing cookbooks in a test-driven way. So a little bit about who I think you are. I think you are someone that's interested in learning more about chef, and that you've written a recipe in a cookbook, whether in production or on our Learn Chef Rally website. You're interested in learning more about testing. So you want to get the idea of what's happening in the world of cookbook testing and how you do that. And you have a belief in the scientific method. So the idea of coming up with a hypothesis, creating an experiment to essentially prove that hypothesis or disprove that hypothesis, and then reviewing the results. Now, before we get started, I just want to say hi. My name is Frank, and welcome to Test Driven Development. So let's answer these questions first and foremost before we get into any of the material. And these come from individuals that I've met over the course of the year and a half that I've started talking about testing in the chef community. And that first one, of course, is why would I even want to write tests? Doesn't chef actually test itself? And for the most part, you are absolutely correct. Chef does test itself. When a chef resource inside of a recipe takes action and it's applied to a system, if it's unable to take action, of course it's going to fail. But it's all about understanding when you want to see that failure. And I'm not saying that most of you that communicate that to me are saying, I want to be testing chef in production. But what you are saying is you want to wait until deploy time. When you're waiting, when you've got your application ready, you're ready to deploy an upgrade to your systems, and then you pull a system out of your pool and you upgrade that one and see if it works or not. And of course, revert back if it doesn't. And what you often find, of course, in this case is when you run into an error, is that you decide, you know what, we should augment that flow. Instead of waiting till deploy time, what we should do is make a small change to our cookbook. Then we should upload that cookbook, right? Upload the cookbook. We should provision a machine that looks a lot like our production systems. We then want to bootstrap that machine, essentially placing Chef on it. And then we want to run Chef Client. Now, this is going to apply the new cookbook and the changes that you would see. And of course, if there was an error, you would definitely be able to detect it. Of course, if there was an error, you would still want to log into that system and ensure the application was working as it's intended, or the system has the correct configuration or settings that you had intended when the cookbook originally was created. Now, this is pretty good, but still, you've got a lot of extra steps or interventions that need to take place here, right? In the entire process of doing this, you are going to, and I'm assuming a human is going to go through and provision that machine, bootstrap it, and then run Chef Client on it. The ad hoc verification doesn't lend itself well to repeatability, right? You logging into a machine, verifying that a user is created or packages are installed, services are started, does not lend well itself for you if you want to take a vacation. And of course, this entire process can be very slow, right? A process like this within your organization may or may not take a long time, right? It probably takes, and I've heard over the past year and a half, that it could take up to 6 months for some of you, depending on what it takes to do this part right here, provisioning the machine. So this is something that is not an ideal workflow. Definitely better than deploying into production, but something that is not entirely perfect as far as how you want to do your work. So great, so Chef does test itself, but you want to look for a way to get this validation or verification earlier in the process. So you then usually, or people usually ask me, what is the difference between an integration and a unit test? Integration test and unit tests, like which one, and that kind of thing. And I want to illustrate this over a number of slides, kind of showing you that integration tests and unit tests in the chef world have fundamental differences. So when we say integration test inside of the chef community, we're meaning that you are writing a test that is verifying the state of the system. And you're doing that through the InSpec language, through the test kitchen tools. Essentially, you'll run a kitchen command to create an instance, converge it, and then assert or verify it that everything is working. And then you're looking at the system. You're writing tests that say, is this package installed? It's almost as if logging into the machine as you did before, but now you've got those scripts that are essentially executing it and doing it automatically for you. And this is different than what we call a unit test. In a unit test, we're looking at the subcomponents of the cookbook itself. We're verifying that the attributes are set correctly, that the resources are taking action correctly as we specified. And we do this through the language of ChefSpec, and we execute our ChefSpec tests with the rspec command. So we're never talking to a system at all. We're just verifying that the code we wrote is correct. So there's some benefits and drawbacks to both of these. When we look at integration tests, the benefit is that it definitely is more accurate, right? Integration tests are going to give you the accuracy of, does it work on this system that I care about? So does it work on CentOS, Ubuntu, right? But the drawback is that it is a slower execution time, and of course it does require some more resources. In this case, virtualized resources, or depending on how you set up Test Kitchen, it may just depend on how much money is being charged to your credit card to do testing on EC2 or Azure. Now, unit testing is going to be far less resource intensive, and it's going to be a lot faster to execute. But you're going to be removed from the reality of what a real system looks like. But again, the focus for unit testing is on, does it do it correctly? Is the code operating correctly? Now, here's a visualization of a big difference of how this works with integration testing and unit testing. So here on the left-hand side, we see that integration testing, why it takes more resources and more time is because it creates a test instance. It installs Chef. It then applies the run list that you specify, and then it executes the tests. Now, for a unit test, it doesn't do any of that, or not nearly any of that. What it does is it builds a resource collection. And we'll talk about that more in the unit testing section later. But the idea is that we really just verify that, are we putting the right things in the list of operations that we're going to perform? And our tests essentially verify that information. So here's examples of two integration and unit tests. And this is where the differences really are more minimal than you would imagine. They're definitely located at different file locations, right? Different file paths. Within your cookbook, you're going to find them at different spots. And for the integration test, when we write this describe user root do it should exist, we're saying that we want the user named root to exist on the test instance. Now, when we write it inside of a unit test, we are saying something completely different. Even if it sounds like we're sort of verifying it on a system, what we're saying is that the username root should exist in the resource collection, right? So that it was added to the things that are going to be done or sort of modified on the system, and so we make sure that it's added to it. Okay. So now, you might be asking yourself, when should I write a unit test or an integration test, right? So you get the idea of the differences between the two. What is the right moment to write either of those? And of course, that is a very difficult question to answer, and something that I think is best illustrated in the case of a particular cookbook. So this is an example of the ARC Cookbooks attributes file. If you take a look at this, there's a lot of information because this is a cookbook that handles multiple different platforms, I think almost all of them. And it needs to determine a number of pre-configured packages that need to be installed on the system. So for us, the ARC cookbook goes through and actually builds the code for you. It retrieves the source code, builds it, and then installs it. So this acts differently on different platforms, and there's different packages required for all of them. So here you'll see that there are a lot of exceptions to the rule when you're on a Mac or FreeBSD, Fedora, SUSE, Amazon, right? All those different things. And you can even see there's some variations on, depending on the version of your platform, what particular packages are available. So this can be really confusing as far as how or what packages I should expect by reading this. From this list right here, this code, it's very difficult for me to determine what packages are available or should be installed on a Mac. What should be on SUSE Linux versus a Debian platform, right? that's something that's difficult for me to mentally figure out. I would need a piece of paper, I would need the matrix of all the platforms for me to determine that result. And this is that moment where I would say a unit test would do a great job for us to determine what packages are being installed for our platforms, and for us to do it very quickly and easily without consuming a lot of resources. Now, that's not to say that a unit test will cover everything and that it will prove that this recipe and this attributes file is working correctly. If we were to look at the tests that we would write for our CentOS 6.7 instance right here, we'll see that it installs these numbers of packages. So this proves that we have created the correct list of packages. But will that actually be the list or names of essentially, will the packages here in this list be the ones available in our CentOS instance? I found that CentOS 6.7, of course, varies between CentOS 6.7 and 7.3. And of course, you may see differences based on just where the provider, who's giving you that CentOS instance, whether it comes from Azure EC2 or something that you've created within your own organization. You might have different repositories for your packages. And so this is a moment where you would actually want to execute this on a real instance, or at least a test instance of the operating system to see that it works. So in this moment, a unit test does give us an idea that we've written things correctly, but we still need a real instance to prove that these packages exist in the package repository, that they're available and they can be downloaded and installed. So a reason for writing integration tests can be considered in this case. We might also be moving from particular legacy scripts or tools that are to an upgraded script environment. We may be moving platforms, right? Like I mentioned, CentOS 6.7 to 7.3. Might want to see those things. We may also be moving from, say, physical on-premise things to virtual or cloud a provider. And in those, we might be using different beginning sort of base images to start from, or operating systems that they provide. So things can be different. And there's a case for writing these integration tests to prove that everything is working for us. Okay, so again, the integration test is verifying the system that's being configured. So if you ever want to verify the system that it's working correctly, you want to use an integration test. And if you want to make sure that the code is working as you imagine that you've written, then you want to use a unit test. Okay, so with those questions answered, let's go into our next agenda item. So you're already one thing down, so let's move into actually writing and executing an integration test. So as I mentioned before, you're going to be using Test Kitchen to execute all of your integration tests, at least in the Chef community. And at the current moment in time, the Chef Development Kit has the InSpec language for it to write your tests in. And so it's going to help you verify the state of your system. Now, Test Kitchen is great because it's going to take care of a lot of those things that you normally would have to do a manual process of creating that instance for you and configuring it and installing Chef and things like that. But it requires a little bit of knowledge, and particularly the Test Kitchen configuration file is the place to start. So most cookbooks that you generate now with the Chef Development Kit are going to give you a kitchen configuration file. If you don't have one, you can generate that one with the kitchen init command. Now, there's a lot more details at the kitchen.ci website, and I encourage you to read that. Here, the kitchen configuration file is going to be stored in a YAML format, and we'll take a look at that. So this kitchen configuration file contains a number of headings, and these headings, or sort of major categories, discuss where they relate to these different steps that I illustrated to you here about creating the instance, installing Chef, executing the tests, and things like that. So traditionally, you'll need or specify a driver, how you want to create your instances. The provisioner will be how you specify how Chef gets installed and how the cookbooks get applied to the system. And then a busser is how the tests get copied to the system. With InSpec, you actually don't need that, but don't worry about those details yet. So a kitchen configuration file is very versatile. So while it works in the world of Chef, it also works for other other sort of configuration management platforms. It also, as you can see here, works on a number of platforms, and in this case, a number of different verifiers. So while InSpec InSpec is our current one by default, you can use ChefSpec or other frameworks to essentially test your code. So there are way more details here at the Kitchen CI website, so take a look at those. Today we're going to be using not Vagrant, but Docker, but those are pretty common ones. Here with the driver, you can actually specify EC2, Azure, other different things if you need it, right? So different sort of ways in which you want to create your instances. Now, every kitchen configuration file, regardless of the drivers and the ways in terms of how they're verified, all those sort of details, the thing that's constant throughout them all is the platforms and the suites. So the platforms is going to be a list of all the platforms that you want to test against. So this is going to be CentOS 6.7, Windows 2012 R2, right? All those different platforms you need. And in the suite section, you're going to find the different test suites that are going to be available for you or that you're setting up. Now, the reason why you want different suites is that you want to be able to say, I want you to apply this run list this time, and I want you to verify it this way. And if your cookbook has multiple recipes, you might define more suites, or you might define custom attributes for each one of those scenarios. So it's depending on what you want. Essentially, each suite allows you to set up different scenarios that you want to test. Now, the number of platforms times the number of suites creates your test matrix, right? So if you can picture it, I've got 2 platforms and I've got 1 suite. Essentially, I've got 2 tests that need to run. Will this suite work on Windows? Will this suite work on, CentOS, right? So those are the things that you want to take a look at. You can verify or look at your kitchen configurations test matrix by running the kitchen list command, and that's going to show you that information. So here's an example of how you would view, say, a kitchen configuration file that is 1 platform, which is CentOS 6.7 right here, and 1 suite, which is the name default. All right, so that's how we sort of create the instance name. It's that essentially the suite name plus the platform name. All right. Okay, so the other important part is with InSpec, the location of the tests are going to be specified. So this is where the verifier is going to say, I want all my tests to be located in this directory. So that's where our tests will be found when you're using InSpec as your verifier. Now, the kitchen tool chain has a kitchen command line application. And these commands that we're seeing on the left-hand side map to those stages that we keep showing you in the middle here about creating the instance and what we mean in terms of like installing chefs, synchronize cookbooks, apply run lists, those things. So the kitchen create command is the one that's really going to take care of using the driver to create the instance for us. When we say kitchen converge, we're going to take care of all that work of installing chef, synchronizing the cookbooks, applying the run list. When we look at verify, we're going to actually look at executing the test. And then there's another command, which is kitchen destroy, which will just do any cleanup for us, deleting our virtual instance, removing it from our memory, deleting it from our Docker run, destroying it from our virtual box or Vagrant, right? So here we would run the kitchen create command, and when we run it, we would see that it was creating our instance for us. So it's going to give us a little bit of output about that instance that it's creating. We run the kitchen converge command, and the kitchen converge command is going to go ahead and then install the chef, as we talked about. It's going to finish the converge. And it's going to install chef and then apply the run list inside of the test suite. So this is going to appear as if you're just converging it on any instance that you've seen before. It's going to resolve the cookbook you need, resolve the recipes, and then attempt to apply it. And then verifying. So after that converges successfully, then we know our chef is at least written without error. Then the verify is going to actually execute the test against it. And it's going to show the results for you here inside of the essentially the output. It's going to tell you, hey, this is what's failed on the system. And here, this is a little closer look at the output. I'm going to spend some time just focusing on it because it's important. Generally, when you see an error, it's going to be red, and it's going to have a big red X, and it's going to tell you a lot more information about it. So if we look at these two errors that are taking place, it's saying that port 80 should be listening, and it actually got false. So port 80 is not listening, right? So we expect it to be listening, but it's not. And we expected the command curl, when we curl localhost, the standard out should say welcome home, but in fact it is not, right? So nothing is coming back. So it's telling us that our application is not set up correctly. And now, of course, we would actually develop it. So this is definitely a good way of seeing it. So you're going to see at the end here a summary. And in that summary, we're going to see what was successful and how many failures and what was skipped. So in our case, we have 2 failures, 0 success, and of course, none were skipped. So there's an important thing to understand when working with your cookbook, and particularly with the kitchen command. When you modify your cookbook itself, you'll want to run the kitchen converge command. That's going to install Chef if it needs to be installed, but then it's going to go through and it's going to apply the cookbook to the system. And then the verify command is going to execute the tests. So if you just make changes to your tests, you'll just want to run kitchen verify. If you're making changes to your cookbook, you're going to make essentially to your recipes, your attributes, anything like that, you want to run kitchen converge and kitchen verify. That's how I combine the 2 commands together on my Mac here to essentially execute them together. That's important to note because there's another command though that you might, we didn't display in the slide there previously when we talked about the commands, but the kitchen test command. Now the kitchen test command is a good command in the sense that what it does is a lot of different steps for you. First and foremost, what it does is whatever stage that you're in, if you have an instance that's been around that you created or converged or executed tests against, it's going to destroy that instance. And then after destroying the instance, essentially for cleanup purposes, it's going to go through the process of creating the test instance for you, installing Chef. It's then going to synchronize and apply the run list and then execute the test. And if everything works correctly, it's going to destroy the instance again. So it does a little cleanup at the end. This is one of those things that is perfect for like a continuous integration platform. So you don't leave any instances around, nothing consuming memory, nothing running in the background, right? It's also important to know that kitchen test is powerful because of that destruction and then recreation of the system. And I strongly encourage that before you commit your code, you run this. So after you've made a bunch of changes and you've run kitchen converge and kitchen verify, that you also run kitchen test. And the reason for that is converge and verify give you faster execution time, right? We're not recreating the instance and reinstalling Chef with converge and verify. We're using the same instance over and over again. And what we're proving each time is that when I apply the recipe, it does not break the system, right? It still converges successfully multiple times. So it's very useful. However, kitchen test is still useful in the sense that it makes sure that when we try to apply our recipe to our system, it'll work on a brand new system, right? And we can explore how kitchen test will show these issues when we get to the exercise portion. But it's definitely a much slower process, and that's why I often suggest that you execute it essentially right before you commit your code. So here again is that visualization of the kitchen commands and the kitchen configuration and how they map to these steps that we've continued to talk about as far as like working with if you were to do your own sort of like test harness and infrastructure if you were to create something. All right, so let's learn a little bit more about the language itself. So we know now how to execute the tests and verify that things are working. But now, what language and how does that work? So we are using now InSpec as the language for us to express the expectations of the state of our infrastructure. This is a change from ChefSpec, which we used before. InSpec is based off of RSpec, and RSpec, of course, is based off of Ruby. It's really, RSpec is a domain-specific language that gives us a way to express our expectations, and InSpec gives us the additional helpers and tools or resources to describe the state of the system. So it's really powerful them working together to kind of give us that work. InSpec has since, initially as an offshoot of ChefSpec, has now further gone on to add its own command line tools and a few other things to differentiate itself further. But for the most part, it's still using RSpec as its core for helping it express the expectation language. So InSpec has a ton of resources to help you express the state of your system. And as you start to work with InSpec, I encourage you to refer to the documentation and the references for each one of these resources, as they provide a number of great examples on how to use each one of them. And of course, if your resource is not here, you can create them with the custom resources or creating your own custom resources that are available. All right. So the language itself, if you look at InSpec, is definitely similar to the chef recipes that you were writing. You are writing Ruby code. You only now have a different, like we said, domain-specific language on top of it. And we'll see here that at the beginning, you might have some OS conditionals that say, like, if this is not Windows, please run this code. And here we see inside of that conditional, we're going to describe the user root, and we're going to say, should it exist or not. So this is saying when not on Windows, I expect the user name root to exist. And actually, this is set up to skip. This is actually how it's set up by default in the InSpec test file. So we'll take a look at that when we actually get to the code. So we can remove that skip line and actually execute that test. But by default, InSpec is going to generate this test for you, and it's going to mark it as skip. Now, we're going to see that within that describe, we can also describe different other resources. And this is where that documentation that I mentioned earlier is going to really help you out. Here, we're going to see that we're going to describe port 80, and it should or should not be listening. In this case, we're saying it should not be listening. So by default, it's telling us that, hey, we don't want port 80 listening. Nothing should be exposed. And that can be important for determining, we want a more secure system or for something not to be running at the time. So this is important for us to write, perhaps for a security perspective. But if you get the gist of the InSpec language here, we can express things in a very natural language way, with the exception of a few little things, right? These little curly braces, the requirement of the do in the end, the underscores between. But for the most part, and this is speaking from someone that spent a lot of time in Ruby, so take it with a grain of salt, that this is pretty clear as far as what is taking place. And a lot of the sort of extra fluff that might go into writing tests steps out of the way. Okay, so let's actually perform a little test-driven development with Test Kitchen and InSpec on our system. So as of today, I'm currently running on my system ChefDK 2.3.4, which comes with Test Kitchen 1.17. I have the Docker 17 installed, and then I've got the Kitchen Docker Gem 2.6.0. Just an important note for those that are perhaps viewing this video in the future. I know how difficult it is to work with different values and things like that. All right, so let's go to the command line, and I'm going to spend some time working with this. So let's get my editor open as well, and I want to open up my kitchen YAML file. So here's the kitchen YAML file for my project. I'm using the Docker driver, as I mentioned before, so that means I'm going to be using Docker to create any one of my instances. I'm using Chef 0 as my provisioner. So this is how my cookbooks are going to be transferred onto the machine and how Chef is going to be installed. InSpec is my verifier, so that's what's going to run the verification of my tests. In this case, we could change that to some value if we need it. And then, of course, here are my platforms and my suites. So this is saying I want to test on CentOS 6.7, and here's my default suite. And the run list for this default suite is the HTTPD cookbooks default recipe. My tests can be found in test smoke default. So let's go to test smoke default and look at the default tests that were automatically generated for me when I created the cookbook. So this is something that I am not interested in, right? I don't want these tests right here, but they're a good first start to kind of take a look at things and how they're working. But before I execute these tests, I want to quickly run kitchen list to show you what is based on, what is sort of the test matrix for my system. You see here, I've got the default CentOS 6.7. There's the driver. I'm using Chef 0 with InSpec as the verifier. And you can see I've got a last state. Essentially, I've been converged. And that means that I've just got this up and running. So I'm going to run kitchen converge again very quickly to kind of give you an idea of what this looks like. So here we're communicating via Docker. We would install Chef if it needs to be, and then we apply the resources that are defined in the recipe. And you'll see that I'm currently converging 0 resources. So there's nothing in the recipe itself. So this is all set up for me. So now I'm going to run kitchen verify. Run kitchen verify, and you're going to see very quickly it's going to tell me from the feedback here that I executed this profile, I targeted your machine, I skipped this test and I skipped this test, and you note here in the test summary we've got the 2 skipped values, and it determined that for me in about 2 seconds, which is really nice. So what our goal now is to write some tests. So here I'm going to describe, in this case, port 80. And I'm going to write that port 80 test that's going to say, I expect it to be listening. It should be listening. Right? So the should is a particular sort of function inside of Ruby, and the be underscore listening is saying what it is. So we could say be available, be, should exist. So this be listening is important. So it's not that. It's essentially should space be listening. So I'm going to run kitchen verify again. And of course, at this moment in time, when I run the test, I'm going to see that it should be listening. I expected port 80 to be listening to return true, but it got false. So again, here it's going to show me that it was failing to verify. And of course, it's returning a non-zero exit code. And if I had this in my build system, it would break and not work for me. So our cookbook isn't doing the work that we'd expect it to do. Of course, this is test-driven development, right? So if we think about test-driven development, the process usually goes something like this. I'm going to define a test that expresses the desired state of my system. Now I'm going to implement a solution and then verify that the implementation meets my desired state, and of course, refactor afterwards. So I'm going to write one more test, and I'm going to write the one that says, I'm going to describe that the command curl localhost, I expect that its standard out should equal, in this case, welcome home. Right? So in this moment in time, what we're saying is it is referring to the command curl localhost. So this is essentially saying grab the standard out from this command. We could also look at the standard error or other sort of other values of it, the return code, et cetera, et cetera. And we're saying it should equal this or match this value right here. Now, this is that moment where it'd be great to look at the documentation. So I'm going to open up inspec.io. I'm going to look at our docs here. I'm going to go to our resources, and I'm going to go to the command. And I'm going to click on command and get an idea of what happens here. So it says it should equal, and it should compare. So compare strings and regular expressions. I think what I want to do is say it compares. And let's just say compare, and I'll use that regular expression like they have here. We could use equal, but I think in our case, I would like to compare instead of that. All right. So now let's return to our command line here. I'm going to execute our test, and I should see a failure. This is going to tell me that it cannot see the welcome home, and nothing is on port 80. So it's now time for us to write our code. Now, a lot of times when writing, a lot of people ask, well, should I start with an integration test or should I start with unit tests? And my answer is usually I start with integration tests when I don't understand the code that I'm going to write. So if I wasn't familiar with the recipe and the resources that I was going to write, I would often start with an integration test to give me the end point in which I want to accomplish. So in this case, I'm going to install the Apache package. I'm going to start the Apache service and enable it. So let's add the action enable and start. And then I want to add one more thing, which is a file. And I want to change var/www/httpd /index.html. And this is where I might not be right, but my test is going to prove this for me. All right, and then the content that I want is hello. Right, and what did I write for my test? Welcome home. Welcome home. All right. Now let's run. So if I run kitchen verify at this moment in time, I'm just going to run my test. That doesn't apply my recipe that I've updated to the system. So I'm going to run kitchen converge, and then I'm going to run kitchen verify afterwards. So we'll see here, here's the cookbook being applied to my Docker instance. It's going to tell me if things are working correctly. I believe I don't have the path correctly on the system. And you'll notice like it's going to say, well, you know what? There was an error creating the system. So we can prove now that my recipe is not correctly defined very quickly using an integration test. Right? This is not something a unit test would actually be able to tell me. So this is one of those moments where, you know what, I'm not familiar with the path, and I'm not sure where that path would be or what that's set up to. I could go to the internet and figure out what the default path is, but instead I'm going to use a trick which is called kitchen login. Kitchen login is going to log me into the test instance. I'm going to know now that the package httpd is installed. I'm now going to look for var www, and I'm going to see HTML. And there's the directory. So it's not HTTPD, it's HTML/index.html. So here's the correct path. So kitchen login is incredibly powerful because it allows me to view the instance as it is, and then I'm just going to exit to leave it. I'm going to run converge again, and I'm going to hopefully see everything pass for us. There we are. Everything passes. Now, does that mean that our website is actually serving up our welcome home page is another question that we can answer by running kitchen verify. There we go. So things were previously red, they're now green, and everything is passing for us. Port 80 is listening, and the standard out of the curl command is telling us that the value is welcome home. All right. So that's it. At this point, we might refactor, we might change the attributes, we might do a few other things, but in this moment, I'm going to continue on because we have lots to talk about. All right, so that's us writing and executing an integration test. And of course, let's talk about writing and executing a unit test. Okay, so writing and executing a unit test is a different target completely than what we saw with the integration test. We are taking a look at the resource collection and verifying the state of the resource collection. And what I mean by resource collection, if you're not already familiar with it, is the idea that during the Chef client run, what happens is Chef will read in all the cookbooks that are in the run list. It will then grab all the recipes that are essentially defined there. And in those recipes, each resource is defined. And it's going to take all those resources and place them in this ordered list of things that it's going to add to the system. And in our case, the resource collection collects up saying, hey, I'm going to do this package. Hey, I'm going to do this file. Hey, I'm going to do this service. Now, the ChefSpec tests are just going to verify. They're going to go through and say, you know what, is this there? Is this there? Is this there? It's not going to actually apply them to a system. It's not going to converge it on my local machine. There is no work that's actually being done whatsoever except creating the list of them and then verifying that they got added to the list as we expected. So let's look at InSpec itself, the tool that we'll use to execute our tests, and see how that works on the command line. Then we'll take a look at the ChefSpec language that we'll write, and then we'll do a little bit of work performing TDD with InSpec and ChefSpec. Okay. So InSpec has a number of defaults on how it works. Generally, the thought is that you're going to be inside the directory of your cookbook. And inside the directory of your cookbook is a spec directory. And any file with the extension _spec inside of that spec directory will automatically be run when you type in the chef-exec InSpec command. So that's really important to know, is that it expects you to be in the cookbook directory, and it expects that there's a spec directory and the _spec.rb file. So those are very important things to be aware of. If you define something without this, it will not find it, not run it. If you're outside of the cookbook directory, you'll oftentimes receive an error that tells you that, hey, the spec directory is not found. So you're going to probably run this with either chef-exec InSpec, or if you only have the Chef Development Kit installed, you might be able to get away with just InSpec. But because I have two Rubies installed, essentially the one in the Chef Development Kit, and of course the one, my own personal Ruby on my system, I use chef-exec InSpec to ensure that I'm using the right versions. You're going to see the output for InSpec run in what they call the progress format. The progress format is just going to give you these little period symbols when things are passing, the stars when things are pending, and the F for the failing examples. Okay. The failures will then be repeated afterwards, right? That's not a lot of detail if that was your only output. So after the essentially the progress format shows all that summary of information and all the tests executing, the failures are going to be summarized, and each failure in order is going to be displayed to you. And the details of each failure are going to show you something very similar to what we saw with the InSpec example. It's going to tell you what it expected based on the test that was written and what it actually got. Here there's a small typo in the path that was actually created, so thus we see that there's a failure in our expectation. Right? It's also going to show you where the specification, where that example that you wrote exists within your test file. So this is telling us in the spec directory under recipes, default_spec on line 30. So this is really great. Later, when you see a number of errors and you want to fix them or learn more about them, you can find that here in the summary of information. All right. Okay. So after all of the tests are, all the failing tests are displayed, you're going to see a summary, very similar to what we saw with the InSpec example. We're going to see how long it took, how many examples were executed, how many were failures, and how many were pending. And then right after that, you're going to see InSpec is going to provide for you what I like to call like sort of the quick way to rerun each of the failing tests. So it's going to show all of the failing tests, but it's going to give you the ability to run each individual one. So you can copy this command right here, put chef exec in front of it, and essentially what's going to happen is it's just going to run this test found at this line right here. So this is great if you don't want to run your entire test suite. You're seeing too many errors and you just want to focus in on one test and only one test. So this is really nice when it does this summary at the end and shows you all the failed examples. So you can also do some additional things to enhance the experience on the command line. You can add color if your operating system terminal supports it. And then I oftentimes change the formatter. I don't like to see the progress format. I like to see it in the documentation format. So this shows me a little more detail about how that works. So you can see, like, I like documentation. It's going to tell me a little bit more of the text that was written for the actual output, which is nice. Okay, so let's learn a little bit more about the ChefSpec language. So ChefSpec is built on top of InSpec, which is built on top of Ruby. InSpec, again, is providing our expectation language, how to express that. But ChefSpec is giving us the ability to express the state of our resource collection. Even though when you write it, it sounds like you're saying that it's installing things on the system or it's starting services, really what you're saying is it's what is expressed in the resource collection. That what's in the resource collection, if it were to really talk to a system, is what it's going to do. So it's a bit of a sort of confusion at first when you read ChefSpec. It sounds like it's affecting a system, but really you're just expressing what's inside the resource collection. Now, there are matchers, was what they call it in ChefSpec. That matches nearly every resource nearly every resource that exists. And even people that create their own custom resources, they oftentimes provide their own ChefSpec matchers. If they don't have them, you can easily create them. It's not a very difficult process, and you can read more about it on the GitHub project for ChefSpec. So here's an example of a ChefSpec file. Inside of it, you're going to find a little bit more detail and more setup than what you see in an InSpec test file. And the reason for that is because, remember, we have to simulate a number of things. We don't have a real system to test against. So what we're doing is we need to make sure that we know which recipe we're actually loading and which resource is essentially going to be added to the collection here. So you'll see here, it'll start with the describe, and then after the describe, it's going to say the cookbook name, : recipe name. And then these example groups are going to be nested together, and inside of that describe, we're going to see this thing called a context. And in this context, we're going to be able to say, set up our different scenarios for different platforms or different scenarios that we want. So in this case, you might say, on Windows, I expect it to act this way. On CentOS, I expect it to act this other way. You're going to see some examples. The examples start very similarly to what we saw in InSpec, but actually they do differ in the sense that you'll notice they'll say, I expect the chef run to not raise an error. Whereas before we usually said it should be listening or something like that, all right? Here, what we're talking about is the chef run. The chef run is essentially a simulated run that's taking place, and we're describing details about it. So we don't really have that it or its as often when we work with ChefSpec. We oftentimes are focusing around the chef run itself, and that doesn't oftentimes open us up to like that easier or more simplified syntax that InSpec provides for us. You'll see, again, here are some additional details. The chef run itself is built by this helper called let chef run do. Inside of this small little unit of code, what we're building is a Ruby class that is faking a chef server run, and it's converging the described recipe, which is, again, the recipe defined above. So this is where it's in memory, faking the run of the chef client, and then creating that resource collection for us. In the previous example, I didn't show you expressing an expectation about a resource taking action, but generally this is what it looks like. Inside of a recipe, we would define our resource, and then inside of our unit test, we would express that we expect the chef run to install the package, or essentially action underscore resource, the name of the resource, right? So if you think of all of them, like in this case, install is the action for package, right? So it's install underscore package. For a service, it might be start underscore service, enable underscore service, create underscore file, right? The different actions that it would take. And that's generally what you're going to use to express the state of most of the resource that you want to test when writing your ChefSpec. Okay, so let's perform some test-driven development with RSpec and ChefSpec. So again, I've got the Chef Development Kit 2.3.4, which comes with ChefSpec Gem 7.1 and the RSpec Gem 3.6. A note about the RSpec Gem. The RSpec Gem is really a meta gem. It contains pointers or links to other gems or dependencies on these other gems. RSpec Core, RSpec Mocks, etc., etc. So those are the gems that actually get installed alongside of it. So if you see more RSpec gems in your system, they should all be about the right version for your Chef Development Kit. The other thing about ChefSpec is that it uses a fake system for OHI attributes called FOHI, and I've got OHI 5.3 installed. The version of FOHI is important because it determines essentially what systems can you fake out as far as what you need. So if you already have Ruby installed, you'll likely be wanting to run chef exec RSpec. For me, that's how I'm going to be running it in all my examples. Like I said before, you may be able to get away with just RSpec, but that's something that's just important. If you run into any trouble whatsoever, just when in doubt, put a chef exec in front of it. So let's perform some test-driven development, this time using some unit test framework. Work. All right, so here's ChefSpec. This is the default file that gets generated for me. You'll note here it tells me for a complete list of platforms, here's this. So there's a comment here inside of it that's telling me about the different platforms that I can set up. Here's the require spec helper. This is loading a file that's inside of the spec directory called spec helper. This is a common file that contains a bunch of common configuration information we might need. Okay, here we're describing the HTTPD's cookbook default recipe, and then we're saying for this platform, when all attributes are default on the CentOS 6.7 platform. Here we're setting up our runner. Our runner is a server runner that is on the CentOS platform with the version 6.7, and we're converging the described recipe. So if we wanted to change it to server, we could, right? But generally the name default underscore spec maps to the recipe that you're converging. Doesn't have to, but that's generally the convention. Here we have our default, essentially, expectation, which is just one of these, this one right here is just assuming that it will run and it will not fail. So there's no errors, no typos, or anything like that. This is a great one that just kind of catches it. So even if you don't write any unit tests whatsoever after today, this is a great setup for your recipe right here, because this is going to catch any kind of typos that you might have in the code that you write. So if you misspell a resource, you forget a do, you forget an end, this is something that'll be really helpful for capturing it. Okay, so I'm going to run chef exec RSpec, and this is going to execute my test on my system. So this should just work because nothing is incorrect inside of my recipe itself, but I'm going to create a typo for myself just to kind of show you that the test is working. Because you should always be afraid of a test that automatically works, because you don't get to see if it's actually giving you value or proving its value. So in this case, the failure is saying I expect the chef run to not raise an error. What it got was what it expected was no exception. What it got was a no method error. Undefined method GE in this case, because I broke apart package into 2 words, doesn't know what package happens to be. Now, we're in a weird situation, right? So we're in this situation where, well, we've got a spec file, we've got the recipe already completed, and now if I was to write a unit test, it seems like I'd be really repeating a lot of the things that I'm doing here. So let me take a moment and split screens. And this is exactly, the moment where you go like, well, I can't do test-driven development because I already actually have the recipe defined. And here's my little trick to you. If you want to perform test-driven development, there's really no difference than it if you were just to comment out or delete the code and start over again. I oftentimes use this as a trick just to make sure that I'm writing the tests and that they execute and that they fail. That's actually the most important part about test-driven development, that you see the test fail. It's not about sort of creating a magic trick or setting the expectation and then meeting that expectation. I'm not cheating by uncommenting this. What I'm proving is that my tests are actually providing value for me. So let's just say it installs the package that I'm interested in. So here I'm going to say I expect the chef run to install the package, in this case HTTPD. I'm going to run the tests. In this case, I should not have an error anymore, like it should pass, but it should fail, and it should tell me the expected package with the install action is not there. And it's going to tell me, hey, I don't see, or if I did see any other package resources inside the resource collection, here's what they would be. Apparently it doesn't. And now I can uncomment this because I see that this fails, so I know that this test is working. So this is another way that I oftentimes use test-driven development sort of approaches. It just really makes sure that everything is working, that the tests are working for me. So the service HTTP services are started, right? And then I would write another one, which is the services are enabled. And I'm going to quickly type this in. And I have a shortcut here that'll save me some time. To, in this case, start the service. And I'll give it the name HTTPD, and I'll copy and paste this here, and I'll change the action from start to enable. All right? So I'm going to run this, ensure that it fails, and then I'm going to uncomment this line right here, and then make sure that it passes. Great. Now here I have my last line, so let's just make sure it writes out a welcome file. And we'll put this inside of here. I expect the chef run to, in this case, it's kind of tricky. Do I really want to say create the file? For right now, I'll just say okay. var www.html / index.html. Let's make sure that it writes out that page. So here we should see, of course, a failure. It doesn't write out that file for me. And now I'm going to uncomment the line that it writes out the file for me. And this should pass. Now, one thing that we could go further is that we could say, well, you see here there's an attribute that's talking about content. We can say with, and then we can say, you know what, with the content, if we wanted to be very particular. Now, with this page, particularly like a small amount of HTML, I don't think I'm interested in seeing the particular content or knowing that a particular file with particular content was inside of there. And of course, I can break it if I'd like to see that this with content is working correctly. Right? So I can use that to sort of verify the state or the contents of a system or one of the attributes essentially defined for a resource here. But in our case, with an HTML file, I'm probably not interested in it. But you may, for some sort of like user that gets created, you might verify that the home is set up correctly or some other values and things like that. All right. Great. So that's us performing test-driven development with InSpec and ChefSpec. And so I want to thank you for your time here, and I want to provide you some additional resources because this is really just a very high view of the test-driven development approach using InSpec and ChefSpec. And so there's a lot more to discuss. First, I want to point you to The Joy of Automating, which is a 10-episode series where I focus on developing real applications using a lot of the approaches that I demonstrate here. So I'm an individual that likes to see examples. I do better if there's more examples for me to understand what's going on. And if you're like that, you'd like to see a few more examples of using testing in these non-trivial ways, I encourage you to check out The Joy of Automating. And here's a link to the YouTube playlist for that. There's also, if you want to look at ways to increase the speed at which you run your tests and how those tests are run, and make it simpler, perhaps simplify the commands for you, for your continuous integration environment, or for you and your teammates, I encourage you to look at this recording called Better Tools for a Better Life. First, I look at text editors, installing some of those snippets and things that help me work faster. I then combine my integration and unit tests into a single command with rake, and then I use guard to run my test every time I make a change to a file. I then spend a little bit of time walking through debugging my code, essentially the recipes or my tests, with this tool called pry. So take a look at that. And then finally, if you're really hungry for more information related to actual InSpec's language and how you can use it to write more elegant tests, you can explore this webinar, this recording that's provided. In it, I look at creating some common helpers to reduce a lot of redundancy inside of my unit tests. This easily translates to things that you might write in your InSpec tests, though I have not found my InSpec tests becoming bloated quite like my unit tests. You can remove those redundancies, and then I even extract it into a portable library at the end of that hour-long session. So take a look at that if you're interested. And last time I did this test-driven development webinar, I walked through and said, hey, you know what? Someone asked, is there a good InSpec book for someone to read to learn more about the language? And my best answer was, here's something that's about 6 years old. Fortunately, in between the last webinar and this webinar, the pragmatic programmers have released a new version of the InSpec book called Effective Testing with InSpec 3. Now, it's going to mostly focus you on creating a Ruby application and writing InSpec tests for a Ruby application. However, it is going to go through some good examples and explain how InSpec works. And so that's something that might be interesting for you if you want to have a good reference about InSpec itself. All right. So with that, we're done, and I want to thank you for your time. Happy testing.